So Thursday, the 12th of November, SWBA students will be able to, you guys will be able to use parallel lines and transversals to find angle measures. Okay, actually that's wrong. Sorry, discuss test. We did that already. You guys will be able to identify relationships between lines and angles. I read the wrong one. Identify relationships between lines and angles, section 4.1. Okay, so first a bit of review. Okay, back from chapter 1. A plane contains a finite number of lines. True or false? A plane contains a finite number of lines.
False.
It is false. A plane doesn't contain a finite number. It contains an infinite number. A plane is infinitely long, and it is what contains other things like lines, points, planes, rays. Okay, not planes, excuse me. Lines, points, rays, segments, shapes. And it is infinitely long in each direction. So there's no limit to the amount of lines it can hold. Okay. Number 2, 2 points lying on the same plane are coplanar. True. If 2 planes intersect, then they intersect at exactly one line. It's actually true. If they intersect at exactly one line. Let's think about it this way, okay? This wall behind me could be a plane.
Yes.
The ceiling could be a plane.
Yes.
The wall and the ceiling intersect
On the floor.
at the entire crease. This line running across.
The wall.
Okay? What?
The wall is peeling off the wall.
Painted.
Oh.
The painted.
In that corner, it's separating. The wall is separating from the wall.
Oh yeah, it is.
Okay.
Mr. Council, come over here.
So, number 4, okay? It should have 2 different blanks. I'm sorry about that. A blank consists of 2 endpoints and all the points between them. A line segment consists of 2 endpoints and all the points between them. Okay? And your 5th blank, I know it's on your paper, but it's not on the notes up here, okay? A blank is made up of an infinite number of points. A line is made up of an infinite number of points. Okay? Hey guys, what do you call it when 2 planes intersect?
Trouble.
A crash.
Wow.
Okay.
No, Dad. Let's call it Dad.
2 lines can do multiple things. 2 lines can intersect at a single point.
Parallel.
So the first one is they can intersect at a single point. Intersect just crossing.
Unless someone crashes.
Number 2 on the top right, 2 lines can
Parallel.
be parallel.
What's that weird dot for?
I don't know. Not supposed to be there.
What dot?
In the number 2 box.
Oh, that's not.
Right below it, it talks about parallel lines. Parallel lines are any 2 or more lines in the same plane that do not intersect or cross or touch. Does anyone remember what the symbol for parallel lines are? 2 lines. It can either be straight up and down, which is less common, or the 2 slashes. They look like a mini set of parallel lines.
It's like right here. So does that mean like infinite planes as well?
Yep.
So that means
Number 3, 2 lines can be the same line. They can be the same line. Sometimes you end up getting 2 equations and they end up being just the same line after all. Yes, Seth?
so that means a rainbow is parallel.
No, because they aren't lines, they're curved. They're parabolas.
Technically, is
Which goes back to algebra 1.
I remember that.
Good. Number 4, 2 lines can be perpendicular. What does it mean to be perpendicular? They make a T. What's the angle measure? They make a specific angle measure, what? 90 degrees, okay? So it makes a right angle, okay? The symbol for perpendicular is an upside down T, okay? It kind of looks like mini perpendicular lines.
With the right angle. Remember, she had his like sailing.
Okay, and then the 5th option, they can be skew. Skew is when they're in different planes and they don't touch, they don't cross. So skew would be like this line up in the top of the room, that corner,
The bottom line.
and
This line over here.
this line over here on the bottom corner of the room. And they don't touch, and they're in different planes. They're not parallel. Okay, let's say this box. Okay, this box. If this front's a plane, this line, the top here, the top edge, and the bottom edge, these would be parallel because they're in the same plane and they don't touch. But this line up here and this line down here would be skew. They're in different planes and they don't touch. So parallel and skew both don't touch. But parallel, same plane, skew is different plane. Okay. And we'll talk about this in a second right below. Hence, parallel lines versus skew lines. So the first thing they actually share, they share that they do not intersect. So neither of them intersect. They both do not intersect. Parallel lines, though, are coplanar, like we just said.
Basically, the brothers from a different
And
mother.
skew lines are non-coplanar.
Basically, brothers from a different mother.
Kinda, yeah. Brothers from a different mother. Okay? Questions on that? Oh my goodness. Okay. Yep, thanks for asking.
Should rise to K, please. We'll get you. We'll get you.
Kevin, no eating in class, please. Thank you. Also, that snack is trash, so I'm really saving you from them because they don't even taste good. All right. So identify the following using this diagram. A line that is parallel to line AB. Can someone raise your hand and tell me line is parallel to line AB, okay? Bailey.
C and D.
Line CD, very good. It's in the same plane as on the top there, and it doesn't intersect. What would be another line that's parallel to it, okay? Dylan. Yeah, line GH would also work, okay? You don't need to list them both, but either of those would have worked.
On ours, it doesn't say.
Dylan copied off my page.
What?
On ours, it doesn't say the
How
line.
did I do that? I can even see.
Yes, but it should.
They're not.
Letter B. I know. B. A plane parallel to plane EFH. Plane EFH is the bottom plane there. Okay. EFH.
ACD.
Okay. Plane ACD, the top plane. Now you can word this top plane however you want. So any three letters you want to use of A, B, C, and D, you can pick them in any order. Kenny.
It would be. Oh wait. Never mind. Never mind.
Okay.
I don't know. I'm confused now, but like no.
Okay, there's no other planes that would be parallel to that plane. Only the one. Just kind of like at the floor. There's only one plane that's parallel. It's the ceiling.
No, I don't.
Yeah, on 4 it does.
Yeah.
On 4 it says line parallel to line.
Yes, I see it that way. Okay. Number on our third option. Okay, on yours it says 3, mine says C. A line that is skew to line AB. What would be a line that's skew to line AB? Okay, Seth.
EF.
Yeah, line EF. Are there other options as well?
Yes, sir.
Okay, Dylan, what's another option?
FH.
FH. We don't need to list multiple, but that is another option. Okay.
And
EG.
And the line is.
CE, DF, okay? There's quite a few, okay? Okay, my letter D, a pair of parallel planes, okay? So skip number 4. Skip number 4 on yours. Go and cross out number 4 on yours. On number 5, though, a pair of parallel planes. Someone want to give me a pair of parallel planes? Okay, Gregory.
CD and EF.
Okay, so be careful. Planes, you have to use 3 letters to name them. So if CD doesn't tell me which plane, because it could be this in the front, because that has CD, or it could be this one on the top, because that has CD. So plane CD what?
CDB.
Okay, plane CDB, so he's talking about this top plane,
And then EFH.
and then EFH is the bottom one, okay? You see how that how we need that third point to tell us what we're talking about? Plane E, F, H. If you just have 2, it's very ambiguous. Once we have 3, it's like, oh, okay, now I know you're talking about the top, not the front. Okay, Seth. Okay, so there's a lot of different combos that could work. Seth, what would be yours?
I put CDF
Yep.
and ABH.
Yep, that would work. Okay, kind of that front and the back. Kenny.
Is this box angled up, or are we looking at it angled down?
I would say that like you're kind of seeing this is the top, this is kind of the side. So you're looking at it from above, and you don't see the bottom, and you don't see this side, and you don't see this side.
Yeah.
So you don't see the bottom or like A, C, E, G, and A, B, H. You don't see those.
But like, wouldn't it make more sense that technically we're looking at it up, and that's why those are dotted lines, because we can see through those to the other side.
But you're looking at it from going down, looking at it because you're above it. Because otherwise, these would be dashed, but they're solid. So those you see those lines from above, but you don't see the lines going on the bottom.
Okay. Alright.
Letter E or number 5 or number 6 for you. Why are lines EF and CD not skew? Lines EF and CD. Why are they not skew? Okay, Elizabeth. They're on the same plane. They're coplanar. Okay, so what are they? What are they though? They are parallel. Yep, very good, very good. All right, let's continue on.
Transversal.
Okay, transversal. So transversal is a line that intersects 2 or more lines. Excuse me, 2 or more coplanar lines. It says lines already. Sorry, 2 or more coplanar lines. 2 or more lines. 2 or more coplanar lines at different points. Yeah, I just said 2 or more lines, botch. 2 or more coplanar lines, okay? At different points. Now, do you guys know what a non-example is? Have you guys heard that before, a non-example? Okay? It's not a good example, okay? Even more than that, it's an example of what not to do, right? Okay? Okay? It's the bad. So I say, hey, be like this, don't be like this. One of those is an example, one of them is a non-example. I'm going to give you guys an example, and I'm going to give you guys a non-example, okay? So, here's the example. Okay, so here's the example. Okay. You have lines B and C, and they're intersected by line A. So you have line A going and intersecting 2 different lines, 2 coplanar lines. So lines B and C are the coplanar lines. And here, line A, I would suggest writing this down. Line A is our transversal.
Basically, it's like a line bisector.
Okay?
Bisector.
Not necessarily bisecting, because bisecting means it cuts it in half. But you can't cut a line in half because it's infinitely long. So you can't cut infinity in half. Because infinity is the concept, it's not a number. So you can't cut a concept in half. But you can cut a number in half, but infinity is not a number. So if we notice here, line A intersects line B up here, but it intersects line C down here. So it intersects them at different points, okay? What was that?
So it has to intersect at 2 points?
So it has to intersect the lines at different points.
What, 2 points?
Yeah, so let's look at this non-example. I think that might clear it up. Okay? So our non-example
Would be going straight to the middle.
could look something like this. You have line E, you have line F, and you have line G. Now, you could say for any of these 3 lines, do they intersect 2 lines?
Yeah.
Yeah, they intersect 2 lines, but they intersect 2 lines at the same point.
Oh.
So that's why it's not a transversal. For a transversal, they have to intersect at different points. Lane, did that answer your question?
Not really.
Not really.
Rip.
Okay? So for the transversal, I had to intersect it at 2 different points. Intersected here on that purple dot, and here on this purple dot.
Like my question was, what if it just like intersects one line?
Oh, then it's not a transversal. So it has to intersect two different lines. Yep. Yes. Good luck.
Don't follow it. Okay.
Yes.
So would it still be transversal if line A was a ray instead, and it started at line B and went down?
Great question. So by our definition of transversal, it says that it is a line, so it has to be a line.
So it wouldn't be transversal if it was
A ray or a segment, no. Yeah, technically it would not be. Yeah.
If it was 3 lines, then it would work.
Then what would
So if there are 3 lines and one of them intersects the other 2.
No, like there's like 3 lines and one intersects all 3 of them.
Oh, yeah. So a transversal can intersect more than 2 lines. Yep. Yeah, so we could add in another line, like line, I don't know, D. And A is still a transversal.
So as long as it just intersects 2 lines.
Yeah, at different points, yeah. Okay. Now, do you guys know what the word interior means?
Yes,
Inside.
Inside. What's
It's
exterior mean? Okay, outside, okay? So interior, and you could say outerior as a joke, but it's actually exterior, okay? So interior angles, all right, we're going to define them as between 2 lines that are cut or intersected, cut by a transversal. So we're going to say that it's between 2 lines that are cut by a transversal. So what is our transversal in this diagram to the right?
2, 4, and 5, and 6.
What's our transversal? What's the line that's intersecting 2 or more lines? M. Line M is our transversal here, okay?
Does that mean technically a graph could be part of a transversal?
Yes.
Wow, that's crazy.
Although we normally wouldn't call the axis a line unless we were to graph from the line at that point.
But what? Okay. Well, okay.
Because otherwise it's just kind of a guide, but it's not actually like, but it's not actually a line. Does that make sense?
Yeah.
It's kind of weird.
So does that mean every line on the graph is transversal?
No. Theoretically, if you drew the other lines, they would be. You just have to draw the lines. But it could be like a transversal for these 2 lines, but not necessarily for these other 2. Anyway, so we want to say between 2 lines that are cut by the transversal. So which 2 lines are cut by this transversal M? K and N. So we want the angles between those 2. So raise your hand for one of the angles between these 2, okay? Elizabeth.
4.
Okay, angle 4 is between these 2 lines. Okay, Dylan.
6.
Okay, angle 6 is between these 2 lines. Okay, Seth.
Angle 1.
Okay, angle 1 is not between the 2 lines. Angle 2 is between the 2 lines. And angle 5, would be the last one. So these 4 angles are all between the 2 lines. Any questions on that? If you don't understand it, right now is the time to ask.
Oh, Lord.
Why is the printer so garbage?
Just to make you ask that question. Okay, so exterior angles are going to be between, not between, but yes, outside 2 lines
The outerior.
that, yes, the outerior, that are cut by a transversal.
I'll go paint the outerior of my house. We should go to the paint store and ask for outerior paint.
Yes.
And it'd be really expensive.
Oh, I'm going to.
So which ones are going to be the exterior angles? Raise your hand to give me one of them. Okay, Christian.
7.
Okay, angle 7. Okay, Elizabeth. Okay, angle 8. Okay, Seth.
Angle 1.
Okay, angle 1. Okay, and then Ray.
9.
Yes, good luck. Okay, Dylan.
Angle 3.
Angle 3. Okay, Kenny, is that what you're gonna say?
Yeah, but I
Dope.
have a good question.
Okay.
So will there always be 4s
Um.
on each side?
Yeah. Great question. Yeah, there will end up being 4 interior, 4 exterior. Just because as we look at it, in our example, like up above here, like up here on drawing,
Yeah.
there's always going to be 4 angles created at each intersection, giving us a total of 8.
Like stop signs.
Okay, kind of, yeah.
Wait a minute.
Yeah.
Can a transversal line be a parallel line as well?
Sorry, say this one more time.
Can a transversal line be parallel?
Transversal can't be parallel to the lines it intersects because then it wouldn't intersect them. But you could have like another line going through here that it's parallel to. Yeah, you could do that.
So you could have two transversal. Wait.
Yeah, you can layer. We'll get into that later actually. Okay. Questions on the interior and exterior angles though for now. We'll get into those in a bit. Okay. Yeah.
So then, does that mean that line B and C would also be transversal lines?
Great question. Yeah, they would be. I like it.
There's a line.
Okay. If you flip a couple pages ahead, okay, you have a table. Go to the table.
No, it's just a piece of paper.
All right. All right. Okay. Okay. That's pretty funny. So, in this table, this is all the first row of the table, but I had to break it up because otherwise you guys it wouldn't be big enough for you guys to read it. Okay? So this is all the first row, okay? This is all corresponding angles. Does that make sense? Okay. So, corresponding angles, we're going to put the description first. Now, heads up for how much you're writing so you know how big to write it. You're going to have 3 bullet points and 1 set of parentheses at the end, just so you guys know. So the description for corresponding angles. There is one that is interior and one that is exterior.
Need some outerior paint.
The second bullet point is that they are on the same side of the transversal.
I don't think you mean exterior. These are double down.
Mr. Consul,
Yes,
do you have any rest on the outerior before?
a little bit.
Didn't your wife get like almost a brand new one and you got an older one?
Yes,
Yeah, that's great. Why?
because I love my wife.
Yeah, he wants her to be safe.
Yep. So the third bullet point is that they are at the same
Like, speed knob.
position
He's hyped. You just can't get his foot up.
at the intersection. They are at the same position at the intersection.
Mr. Consul.
Yes.
You were speeding in the parking lot the other day.
What?
Yeah, you were just zooming.
I feel like you're making things up.
No, it was your little small white car, right? Yeah.
The G5?
Yeah.
Now he's gonna
You
hit
were like,
you.
meow, right in the parking lot. I was like, jeez.
Now he's gonna hit you the next time he sees you.
Um,
Snitching like that, Dylan.
in parentheses here, I want you to put that they are on the same side and same spot.
Mr. Consul, how fast do you go on 75?
75? That's none of your business.
He's going
Mr. Consul is rolling 100 down 75.
Yeah, if you swing, shake your head, it looks like 102.
On the
Alrighty.
highway, everybody watch for Mr. Consul.
You won't be able to see him.
Alrighty.
Alright, get him, boys.
Hey, Mr. Collins.
Yeah.
He's yelling at that. He just has like a speaker that's yelling out.
Whatever,
red
what?
notes as he's driving
No.
by.
What straight pipe is
Yo,
called?
Mr. Consul.
I think straight piping is unethical.
No, Mr. Consul, do a muffler delete.
Isn't that the same thing as-
Muffler off.
Yeah.
Bring two exhaust pipes and weld it.
Yeah, that's literally what straight piping is.
No.
There's a difference.
Yeah, there's a difference.
I
What's
can't
the
tell you-
difference?
I can't tell you what it is, but there is.
What is the difference?
There's a difference.
There
What is
a-
it?
but, like,
There's
just pretend like
Oh,
there-
yeah, there's totally not, because that's literally what straight piping
What's
is.
reverses, exhaust manifolds, and
Let's
Let's
straight
just
out the
spin up your
hose.
whole entire exhaust
Yo.
system.
Bring the head right up.
Okay. Anyway, corresponding angles. So there's one that is exterior, one that is interior. They're on the same side of the transversal. So if we look up here at the picture, this is the transversal, okay? This is the transversal. Is that clear enough for you guys? Okay, that's the transversal.
Oh, we don't do
Now they're going to be on the same side of the transversal. One's going to be interior, one's going to be exterior. And they're going to be at the same position at the intersection. Meaning, at this top intersection, let's say one's at the top left. The other one's going to be at the top left of the other intersection. You're not going to have one at the top left and one at the bottom right. Okay? Does anyone think they have a pair of corresponding angles in this picture? Elizabeth.
1 and 5.
Angle 1 and angle 5 are a pair of corresponding angles. Angle 1 and angle 5. They are on... Angle 1 is an exterior angle. Angle 5 is an interior angle compared to those, the two lines cut by the transversal. They are on the same side of the transversal. They're both on the left-hand side of the transversal. And they're both in the top left of their intersection.
Angle 2 and angle 6.
Penny.
Okay. Tyler, thank you for raising your hand. Tyler, what about you? Angle 2 and angle 6 would be a pair of corresponding angles. There's one that's interior, there's one that's exterior, both on the right side of the transversal, and they're both in the top right of the intersection. Okay. Seth.
Angle 8 and angle 4.
Okay, angle 8 and angle 4. It doesn't matter the order you put them in. Angle 8 and angle 4. One's interior, one's exterior. They're both on the right-hand side of the transversal.
Angle 8.
And they're both in the bottom right of the intersection, okay? Let's go with Dylan.
3 and 7.
Angle 3 and angle 7. Very good. The last two. They're both in the bottom left hand. One's interior, one's exterior, and they're both on the left-hand side of the transversal. Now, in the parentheses, I put this thing, same side and same spot, meaning they're in the same side of the transversal, and they're in the same spot at the intersection. If you can remember those two, the interior-exterior will come in line, okay? So if I can remember, I need the bottom right of the intersection, so I need the bottom right of the other one. 4 and 8, okay?
Always going to be at least 4.
Okay, does that make sense to you guys or no?
Yes, sir.
Okay, yes.
Shady.
Okay, alternate interior angles. This one you're going to have 2 bullet points.
You didn't do facts.
You're right, we're not doing facts yet.
Screw the facts. The facts are math.
These are both interior, which we can shorten up to be INT if you want. They're both interior, which we can shorten to be INT. Notice, alternate interior. It's in the name, right, that they're interior?
Yes.
Okay, you get ready for the second one. They're on opposite sides of the transversal.
That's crazy.
Do we see anything in their name that would indicate they'd be on opposite sides of the transversal?
The alternate.
Alternate. What's alternating mean?
Every other.
Every other, it goes back and forth between 2 different things, okay? That's what alternating means. It goes between 2 different things back and forth, okay? So it's alternating. It's on different sides of the transversal. One's on the left, one's on the right, vice versa. But they're both inside the 2 parallel lines cut by a transversal. Does anyone have a pair of alternate interior angles they would like to share? Okay, Seth.
Angle 3 and angle 6.
Angle 3 and angle 6 would be a pair of alternate interior angles. Angle 3 is on the left, angle 6 is on the right, but they're both interior. Raise your hand for the other pair, okay? Elizabeth.
Angle 4 and angle 5.
Angle 4 and angle 5 is another pair of alternate interior angles. They alternate sides of the transversal. They're both interior, those 2 lines cut by the transversal. Does anyone think they can see another pair of alternate interior angles? Okay, Seth?
Angle 4 and angle 6.
Angle 3 and angle 4.
It's impossible.
Okay, angle 3 and angle 4. So those alternate sides of the transversal, and they are interior. So I get what you're saying. But those are actually going to be ones we don't classify because they're at the same intersection. I love that we're going with it, though. But they're at the same intersection. So they actually need to be at different intersections for these angle relationships. Great question. I'm happy you brought that up. Tyler.
Angle 2 and angle 7.
Angle 2 and angle 7. Are angle 2 and angle 7 interior or exterior?
Exterior.
Exterior, so they can't be alternate interior then. Does that make sense? Okay, I love that. I love it though. Gregory.
1 and 6.
Okay, 1 and 6. Are 1 and 6 both interior?
No.
No, so it can't be. Okay, it doesn't quite fit it. Okay, Bailey. Okay, you're stretching. Let's move on to alternate exterior. Okay, what do we think the first bullet point for this one's going to be?
Opposite outside.
They're both exterior.
Both out here.
X.
They're both outerior. Okay, what do we think our second bullet point's going to be?
Opposite sides of the transversal.
Opposite sides of the transversal. Okay,
Is it bad that-
which word tells us that they're on opposite sides of the transversal?
Alternate.
Alternate. Which word tells us that they're both on the outside?
Exterior.
Exterior. Opposite sides of the transversal. Can anyone give me a pair of alternate exterior angles? Okay, Kenny.
1 and 8.
Angle 1 and angle 8, I'd agree. They're both exterior, and one's on the left-hand side, 8's on the right-hand side. Okay, Gregory.
2 and 7.
Okay, angles 2 and 7, I would agree with you. They're both exterior, and they're on different sides of the transversal, okay? Do we have any others?
No.
No, because they're all any others would be at the same side of the same intersection.
Or they'd be corresponding.
Or they'd be corresponding, or they'd both be interior, okay?
Or they could be negative.
Consecutive, or same side interior angles. What does consecutive mean? Okay, Bailey.
Can you go back a bit? I haven't got the example.
There you go.
Sir Carlson, what if we really pranked you and take out your transmission?
I think that's more than a prank.
Can we borrow your drive shaft?
Hey, did you know if you do it?
Why don't you just borrow the whole drivetrain?
Exactly.
Hey, Mr. Consul, did you know if you take a Ford and do an engine delete, it's the same thing because they don't run anyways?
Wow. I can tell you the Fords are still running. Chevys.
That's kind I mean, regardless of your company affiliation, if any, I mean that's kind of a funny joke. Okay, consecutive or same-side interior angles. What does consecutive mean?
They're on the same. They're on the same.
Okay, not necessarily. Consecutive means in general
One after the other.
one after the other. Consecutive means what? One follows another. 3 and 4, 4 and 5. Okay. Okay. So there's different things that are consecutive. They just follow each other. Okay. 9th grade and 10th grade if you pass. Okay. So. I mean, I need to put the qualification on there, you know. Some of us might struggle passing our classes. Okay. Anyway. So there's going to be 2 bullet points for this one. Okay. So this one, they're going to be both interior because it's in the name. And these are going to be the same side of the transversal.
Can we borrow your your passenger side door?
Sure. It's missing the door card anyway, so that works.
How?
I bought it like that.
Oh, okay. I thought maybe you just like decided you didn't need it.
Nope. I actually need to get one for it. No. You can't borrow. You can't borrow all 2 of them.
2?
Yes, it's a 2-door car.
What about your
It's a coupe, not a sedan.
It's a coupe.
Yeah.
Can we do a
My sister's boyfriend is a coupe.
Oh, that'd be perfect.
Can we do a rally swap?
Okay. So, does anyone have an example of same side or consecutive interior? Tyler.
Same side. So 1 and 2.
So are 1 and 2 on the same side of the transversal?
1 and 3.
Okay, 1 and 3 are on the same side of the transversal. Are they both interior?
No.
3 and 4.
Gregory.
4 and 6.
4 and 6. Angles 4 and 6 would be a pair of consecutive or same side interior. If you kind of look, do 4 and 6 look like they're one after the other if we just kind of go down the row? Yeah, and they're on the same side of the transversal and they're both interior. Now we'll use the word same side a lot more than we'll use consecutive. They can be called either, but we're going to call them same side interior angles way more, okay? Yes, Dylan.
Angle 3 and 5.
Okay, angles 3 and 5 as well. Are there any others that would be consecutive or same side interior angles?
No, not 4 and 6. 1, 3.
4 and 3, are those on the same side of the transversal?
No.
No, okay, even though they are interior, they're not on the same side of the transversal, okay? So these are the only 2 pairs.
You have felonies, Mr. Castle.
Not that I know of. Same side exterior angles, okay? So these are going to be both, what, exterior, both outerior. And these are going to be on the same side of the transversal, hence the name. Are we seeing the descriptions, are we seeing the names for these basically tell us the description?
Yes.
He's running a monkey mom crime family.
Dylan, are you trying to give me an example of it?
Yeah.
Okay, I'll have you wait. Raise your hand if you want to give me a pair. I'm going to call on someone new this time.
What? Oh, I knew.
Okay? Quentin. Give me a pair where they are on... Tyler, stop. Give me a pair where they are both exterior and they're on the same side of the transversal.
1 and 7.
Angle 1 and angle 7. Very good.
2 and angle 8.
Okay? Does someone else want to raise their hand that's new and tell me another pair? Tristan. 2 and 8. Kevin, is that what you're going to say? Kevin, thank you for volunteering by raising your hand. Questions on this?
I feel attacked.
Christian.
Could we raise your car and put tractor tires on it?
Sure.
Ooh.
Okay.
What tractors? Put a track on it.
That sounds great.
Tractor tires.
I talk about vehicles, yes, but I just want to do math.
Okay. Questions?
Return your car to an APC.
Yes.
Why?
This is
Why
now
UFO?
math vehicles are class now.
Let's just strap on a.
Hey, math isn't large and
Let's turn
vehicle.
your vehicle into a plane.
So, hover car.
How?
Can we get
Well,
two
technically a car
vehicle
engine can
subjects
go
in math?
plane.
Then-
That's brother.
Can we look at practice? Can we look
Voices off, please and thank you. We're going to go back to the bottom of the page we were previously on, the second page. And you should see this. Do you guys see this where you're at?
No. I see something similar.
Okay. I want you guys to fill in these 4 blanks. Give me a pair of alternate exterior, consecutive interior, aka same side interior, alternate interior, and corresponding.
What the heck? Oh, what the crap. Are you looking to repaint your car, Mr. Carlson?
I'm just like
Bright yellow, like construction grade yellow.
It's like you're painting.
Kenny, are you looking to finish up this problem?
Yeah.
Yes, Bailey.
You should paint the Africa on your car.
You should write in the answers to these problems.
I know, but as you say.
Hey, man. Yeah.
I still can't find it.
Okay, so it's the second page of the notes. So go back to the first page of the notes, and flip one page. Yep, inside at the very bottom. Thanks for telling me. You have it, Seth? Or you think you do at least? Oh, that's confidence.
Oh, I did this one, Don.
Mr. Carlson, I did it.
I'm a human.
You're human?
Yeah, he said dog. What's up?
Good job, you finally admit
all
you're
the songs on your car.
Of course, okay? Yes, good luck, okay? Raise your hand if you want to give me a pair of alternate exterior angles, okay, Kevin?
1 and 7.
1 and 7, very good. Okay, raise your hand if you want to give me a pair of same side interior angles, okay, Landon, thank you.
Same side interior.
Yep, consecutive interior, same side interior.
Angle 4 and 5.
Very good, angles 4 and angle 5. Raise your hand if you want to give me a pair of alternate interior angles, okay, go ahead, Elizabeth.
Angle 4 and angle 6.
Awesome, angles 4 and angle 6. Cool. Raise your hand if you want to give me a pair of corresponding angles. Christian.
Angle 1 and angle 8.
Not quite. Angle 1's at the top left and angle 8's at the bottom left. Kenny.
Angle 1 and angle 5.
Angle 1 and angle 5. They're both at the top left of their intersection. Angle 1 and angle 8 would be same side exterior. Okay? Additionally, I want you guys to write these in. I want you guys to give me a pair of vertical angles and a linear pair. Don't blurt. I want you guys to give me a pair of vertical angles going back from chapter 1 and a pair of a linear pair going back to chapter 1. That's the spirit. Raise your hand if you can give me a pair of vertical angles. Elizabeth. Okay? Kenny?
Isn't it like 1 and 5?
Not 1 and 5. Those are corresponding.
Okay.
Okay, Christian.
Would it be 1 and 2?
Nope. Ray.
1 and 8.
Nope, those would be same side exterior. Kenny.
Wait.
Angle 4 and angle 1.
Nope.
Angle 1 and 3.
Angle 1 and angle 3 would be... Angle 1 and angle 3, they're on different sides of this X. They're on opposite sides of the X. What do we know about vertical angles? They are always, always, always
The same.
congruent. What would be another pair of vertical angles? 4 and 2, 5 and 7, 6 and 8, and they're always congruent. What would be a linear pair? Raise your hand to give me a linear pair.
Would that be 1 and 4?
That would be 1 and 4, for example. Angle 1 and angle 4. You could also do angle 1 and angle 2. Linear line. Pair two angles. Two angles will make a line. Angle 1 and angle 4. They're next to each other and they add to 180. Question on that? Okay. Go on to the next page. Letter A, don't blurt. The transversal is line blank. Ryan, what are you thinking? The transversal is line? R, I agree. R is in rhinoceros. Or red fire truck. Okay? B, corresponding angles are on the blank of the transversal. Corresponding angles are on the blank Same side
What I said.
of the transversal. Very good, Dylan.
You're welcome.
Name 4 pairs of corresponding angles. Lauren, give me one of them. Not quite. Those would be same side interior. So 7 is at the bottom right of the intersection, where 6 is at the bottom left. Can you try again, Lauren? Or you want me calling you in a bit? Well, I'll call you in a bit, okay? Christian.
Angle 8 and angle 7.
Nope, those are a linear pair, angle 8 and angle 7. Elizabeth. Angle 1 and angle 2 are also a linear pair.
Angle 1 and angle 3.
Angle 1 and angle 3.
That's what I was gonna say.
Top left of their intersections.
I got one.
Okay, Dylan.
Angle 8 and angle 6.
Angle 8 and angle 6. Bottom left of their intersection. Okay, Lauren, you ready to give me one now? Angle 4 and what? Angle 4 and angle 2. Top right of their intersection. Ryan, do you want to give me the last one?
7 or 5.
Angle 7 and angle 5. The order we put them in does not matter, guys.
Oh.
And those are both at the bottom right of their intersection. Correspond means they go together, okay? So we're saying, hey, they're in the same spot at the same intersection, okay? Questions on that? Alrighty, we have this thing called the corresponding angles postulate. Okay, I'll go back here for people to write it down.
Bada bing, bada boom.
Kenny, good luck.
Don't ask questions.
Okay,
I'm gonna go and swim.
corresponding angles postulate. Reminder, postulate is something we accept to be true. And we build other things off of that. Corresponding angles postulate: when two parallel lines that are parallel, are cut by a transversal, the resulting corresponding angles are congruent. When two parallel lines are cut by a transversal, the resulting corresponding angles are congruent.
That's the lesson.
Now, do you guys see how I have this picture of two lines cut by a transversal right now?
Yes, sir.
Okay.
Who wants to put it down?
Now,
Oh.
you don't have to draw it down, but I want you to look up here with me. Okay. Quentin. Give me an angle measure for angle 1 that looks like it might be accurate. Okay, angle 1. What do you think that might be? How many degrees do you think, buddy?
145.
Asking Quentin, not Dylan. There's no wrong answer, really. What?
I don't know.
Okay. Presley, give me a measure that you think could be fit for angle 1 up here. Like angle 1, give me a measurement for it. Like it's this many degrees. Cool, 120 degrees. Sounds good. We'll call angle 1 120 degrees. Now, what if I tell you that if we know this angle, we could find the other 7?
I believe you.
Okay? So, we're going to say that these lines are parallel. They look to be parallel, don't they? M and N. Now, according to our corresponding angles postulate, what could we know about corresponding angles since these two lines are parallel?
All the rest of them. There's 3 others that are the same as that.
Okay, there's going to be some angles that are the same as 120 degrees. What angle is the same as 120 as angle 1? Elizabeth. Angle 5, they're corresponding angles, so they're congruent. So this is also 120 degrees. Because those two parallel lines are cut by a transversal, the corresponding angles are congruent. Kevin, what's another angle we can know? We can know angle 4. How could we know angle 4? I agree with you. Okay, they're congruent to angle which one? Angle 4 is congruent to angle 1 because they're vertical angles, so they're always the same measure, regardless of whether we have parallel lines, okay? Dylan, give me another angle we could know.
8.
Angle 8, how could we know angle 8?
Because it's the same as angle 5.
It's because they're what kind of angles?
Or they're vertical.
Vertical angles, so they are congruent. Now wait, could we also know angle 8 because we know angle 4?
Yeah.
Because they're what kind of angles?
There's
Corresponding. And corresponding angles are congruent. It's because those lines are parallel, okay? Raise your hand if you can tell me another angle we could find, okay? Seth.
2 is 60.
Angle 2 is 60 degrees. How did you stumble onto that fact?
Because 120 minus 180 is 60.
Okay, so if we take 120 away from 180, we get 60, okay? Well, why did you take 180 subtracted 120?
That's all the numbers you know.
What do you mean?
Because 180 is minus 120 is 160.
Okay, but why 180? Why didn't you pick 200? Why not
Because 180 is how much you could have on a straight line.
on a straight line? So what two angles add up to be a straight line here?
1 and 2.
Well, angle 1 and 2 are a linear pair, so they add up to 180. Now wait, is angle 2 and 4 a linear pair as well?
Well, yes.
Yeah, so you could have found it with angles 2 and 4 if you wanted instead of angles 1 and 2. Now raise your hand if you can tell me another angle we could know, okay? Elizabeth,
Angle 7.
how could we know angle 7?
Because it's corresponding. No.
Go with your own explanation.
So, it's in line with 2.
Not with 2. Okay, we'll reload, try again later. Gregory, what's an angle you're thinking we could find? Okay?
Subtract 120.
From
If you subtract 120 from 180.
okay, and so it's a linear pair with which angle?
2.
Nope, not with 2.
1 or 4. Wait.
Angle 3 is a linear pair with what angle?
1 or 4.
Linear pair, line pair, pair of angles that add to 180.
4.
Angle 4 or angle 1, either one, honestly. Now it's also vertical angles with angle 2, right? So they're congruent. Is that true? That it's vertical angles with angle 2, so they're congruent. Is that true? Okay, guys, make sure you're paying attention up here. We're not writing this down, so you need to be paying attention up here. Okay? Raise your hand if you can give me another angle we could figure out now. Raise your hand if you can give me another angle we can figure out now. Okay, Ray.
7
Okay, how could we know angle 7?
is the same thing
As,
as you did 1 and 3. Yeah, 1 and 3.
okay, so 7 and angle 7 and angle what?
3.
5.
5 are a linear pair, so they add up to
180.
180, so it's 60 degrees. Now, how else could we know angle 7?
It's parallel to angle 3.
Not parallel to angle 3,
Okay.
congruent to angle 3 because they're corresponding angles. How else could we know angle 7?
Because that's what everything else is.
It's an angle 2.
It's a linear pair to angle 8. Very good, okay? Now, raise your hand if you can tell me another angle we could find. Okay, go ahead, Dylan.
6.
How could we find angle 6?
See, you take the 120 from number 5.
Okay?
Not 5, subtract.
So it's a linear pair with angle 5. How else could we find angle 6?
It's congruent with
7.
Okay, it's a vertical angle with angle 7, so they're congruent. How else could we find angle 6? Congruent with 2 because they're what kind of angles? Corresponding. What else? How else could we find angle 6? It's a linear pair with angle 8.
It's also the last one.
So angle 6 is in a linear pair with angle 8. They form a straight line. Isn't that kind of neat? From one angle and knowing the lines are parallel, we are able to find the other 7 angles. I think that's pretty cool. Okay? Now, here, we said corresponding angles were congruent, right? When the lines are parallel. Okay? So let's go back to our table for a second. The first spot on our table, corresponding angles, go to the facts. We're going to put in inside the facts box at the very top, when 2 lines are parallel. What do we know about corresponding angles when the 2 lines are parallel?
They're easy to figure out.
Because they are congruent. When corresponding angles, when 2 lines are parallel, when the 2 lines cut by the transversal are parallel, corresponding angles are congruent. That was our postulate. Now wait, let's look at alternate interior angles. Let's go back to this picture here. Give me a pair of alternate interior angles. Elizabeth. 3 and 6. What do you notice about angles 3 and angle 6? They're the same number. They're congruent. Give me another pair of alternate interior angles. Okay, Dylan.
4 and 5.
4 and 5. What do you notice about angles 4 and 5? They're congruent. So when the two lines are parallel, alternate interior angles are congruent. So this is for alternate interior angles in the table. This is for the table and alternate interior angles. We're on the table right now. Corresponding angles were congruent when the two lines are parallel. Alternate interior angles are congruent when the two lines are parallel. Let's go back to the picture again, which you don't have to flip your page for at all. You just have to look up here. Give me a pair of alternate exterior angles. Ryan, give me a pair of alternate exterior angles.
1 and 7.
Those are same side exterior. Try again, Ryan.
Yeah, 1 and
1 and 8, alternate exterior angles. Now, what do you notice about those alternate exterior angles, Ryan? They are congruent. They're the same measure. Give me another pair of alternate exterior angles. Ray.
1 and 7.
Not 1 and 7, but
Or
2 and 7. What do you notice about 2 and 7? They are congruent. So alternate exterior angles, when the two lines are parallel, they are congruent. Go ahead and fill this in your table.
I did.
Okay?
The back's all congruent.
Now, somebody give me a pair of same side interior angles. Elizabeth. 3 and 5. Now, what do you notice about angles 3 and 5?
They're not the same.
They add up to 180.
They're not congruent, but they do add up to 180. What's it mean if they add up to 180? Supplementary. Give me another pair of same side interior angles. Ray.
4 and 6.
4 and 6. That we're going to say, Christian? Okay.
They're also
4 and 6. And they're also supplementary, aren't they? So when the two lines are parallel, same side interior angles are supplementary, meaning they add up to 180 degrees.
Can you return paint?
unless you never used it.
Like, I mean, if I could buy a can of paint. You didn't like
Most-
open it, what's
most-
the wrong color?
Most stores, yeah. So give me a pair of same side exterior angles, Landon. 1 and 7. Are 1 and 7 congruent?
No, they add up to 180.
No, but they add a 20. They're supplementary. Give me another pair of same side exterior angles, Bailey.
What?
Give me another pair of same side exterior angles. We said 1 and 7 are 2 and 8. They're on the same side of the transversal and they're exterior. Now those aren't congruent, but they are supplementary. Very good, Presley. Very good, Seth. So same side exterior angles when the two lines are parallel, they are supplementary. One thing I want you to notice about this table. How many were congruent? How many were supplementary when the two lines are parallel? 3 congruent, 2 parallel, or 2 supplementary, excuse me. Which 2 were supplementary?
The same sides.
Same sides. And notice, same side supplementary. SSS. You guys kind of notice that alliteration there? Those multiple letters in a row. Same side interior, supplementary. Same side exterior, supplementary. SSS. Does that make sense a little bit more maybe? Okay. SSS. Same side, they're going to be supplementary when the lines are parallel. Alternate exterior, alternate interior, corresponding, congruent. Yes.
What was it said for alternate exterior angles?
Congruent. Okay?
Mr. Castle.
What?
Everybody's always telling me I don't make sense because I don't have a job.
Nice. Okay. Given the lines are parallel, find the missing variable. Let's go past the table. Or do not past the table. Let's go, we're at the bottom of the page before the table.
That is 4.2.
We're at the bottom of the page before the table. Okay.
This is great.
What if I tell you you don't have homework today?
Oh, good.
All of a sudden you're okay with it? Cool, okay? So, what kind of angles,
Get walking.
what kind of angles are these two angles here?
Those are.
Supplementary.
No, they're not supplementary.
What kind of angles of our 5 angle types we talked about? Corresponding, alternate interior, alternate exterior, same side interior, same side exterior. Raise your hand, Lauren. Very good. They are alternate exterior. We can shorten it down to alt-X if you want.
Maybe.
What kind of lines are there? They're alternate exterior, and I'm actually going to put angles on there. Alternate exterior angles. So if those lines are parallel, which, guys, given those lines are parallel, What do we know about alternate exterior angles? Are they congruent or supplementary?
Congruent.
Congruent. So could we set up an equation to solve for A? What would be the equation we could set up for A if they're congruent? Congruent tells us to do what with them?
Do nothing. Just make them look parallel.
What'd you say?
Is it 2A plus 10 equals 3A minus 15?
2A plus 10 equals 3A minus 15. If they're the same, that means they're equal. Congruent means they're the same measure. If they're the same, that means they're equal.
There's like two equations that equal the same line or same.
No.
No.
So we get this equation because they're congruent. When we hear that things are congruent, cowbells should be going off in our head telling us to set them equal.
Put the ring in it.
How would I solve this equation? 2A plus 10 is equal to 3A minus 15.
Cowbells with same.
Minus 3A, minus 2A.
Subtract the 2A. We want to get all the A's together, so we have to move the 2A across the equal sign by subtracting it. 10 is equal to what? A minus 15. Now I got all the A's on one side. I want to get the constants away. So what am I going to do with the negative 15?
Add 15.
Add 15 to the 10. Yes. What is 10 plus 15? 25. Ha ha ha. Equals A. So what is A?
A is 25.
25. Now could we plug it back in to find the angle measures?
We could, but are we?
Sure, let's try it real quick. Let's plug it in the top. What is 25 times 2? Because it's 2 times A. 50. What is 50 plus 10? 60 degrees is this angle measure. Let me write that not over the orange. 60 degrees is the angle measure. What is 3 times 25? Think of 3/4. 75 minus 15. 60. Are these the same?
Yeah.
Are they supposed to be the same?
Yeah.
Yes, because they're they're alternate exterior angles. Questions on that? We are going to end our lesson here for today.